Hello, and welcome to this wonderful presentation, Map and Molecule, Building the Enterprise Holograph, a presentation by Daniel Taylor. He put himself here as a semantic engineer, but Daniel is so much more. I mean, he's been a veteran of marketing and advertising for over 2 decades, and he has a ton of experience in everything to do with marketing analytics, semantics, and integrating, delivering this as a useful means of decision making information for the executive staff. He's also built teams from scratch. Anyways, I'll let Daniel introduce himself and talk a little bit about the premise of this presentation. The floor is yours, Daniel.
Thank you, sir. How does your data make you feel, or even the word data, the idea of data? In too many cases, it comes with a stab of anxiety, a feeling of weight, even dread. For years, we've built miraculous things based on what we could do with the technology we've had, but that's been limiting. And in order to put everything back together at the end of the day, we've multiplied complexity upon complexity, and we've paid the cost in both finances and in human capital. We have data for things because we care about them. And the things that we care about and interact with regularly are things that we should be able to feel natural and comfortable and fluent about. With that in mind, I am here to describe a new way of thinking about data and information, which I call a holograph. In this case, because it contains all the features required for business use, I'm calling it an enterprise holograph. The goal is a human-centric, flexible, and evolvable approach to information based on the processes of our own intelligence, but also maintaining high ethical and technical data standards. In addition to being human-centric, it embraces the data-centric paradigm, including important principles like the instructions and objects in this system are written in language that humans or machines can understand. It's data that belongs to you and is portable and reusable. It's not locked away inside a platform. And the work you put into building this and the data you put into it is immediately useful to yourself, but also developers and partners making future projects, even moving to a different platform, orders of magnitude easier and cheaper. We think of ourselves as individuals, and indeed the question of identity is at the heart of this new paradigm of semantic graph data. We are compound organisms, though. Most of the genetic information that makes us and keeps us working comes from the microbes and the viruses that we contain rather than our own DNA. And what lets all those parts work together is a shared language of amino acids and proteins. And in the same way, a holograph is not a big clockwork monolith, a Rube Goldberg device, but an information ecosystem held together by shared language. At the heart of the matter is something that feels like a contradiction or at least a tension. Data is physical in the sense that it has an existence, it's written down, it's discrete. We're responsible for it. We're past the days when it was acceptable not to keep track of where it came from or when we got it. Now we have to be able to remove erroneous data or worse, toxic data without breaking the system. These are ethical and even legal requirements. Concept formation, though, the world of ideas, of abstraction, is different. As we build the system and name things and describe the parts, we're going to be wrong. It's just going to happen. It's part of the process. And we're going to learn to see things more clearly and get better ways of understanding things. That's the kind of behavior that this technology needs to support. Previous data paradigms that make structural transformation difficult are discouraging us from doing the most important and most consequential things. The power of concepts is that they can be reused, extended, and even change in different contexts, and as with the data side, without violating the integrity of the system. With all that in mind, this is a holograph. It's not a product, it's an idea or a set of ideas that can be used to build a coherent, harmonized system that has both flexibility and integrity. At the core of the holograph is a data repository, a permanent record in which both raw and semantic and structural data are saved, with notes about where they came from, when changes were made, when we acquired them. This is the part that is auditable and and editable in immutable in the sense that it captures all the changes that have been made in objects and in structures with time. That data core is surrounded by a knowledge graph layer, not a single knowledge graph, but this compound organism of subgraphs that describe objects, rules of logic, relationships, processes, ways of validating information. And the structures in the knowledge graph render that semantic data into objects, into this world of graph objects, in which all kinds of different things exist as things that we understand, things we care about, things we give a name and attach named attributes to. There are many, many attributes for all these objects, though, more than we would ever really want to look at. So most of our interaction with them happens through this halo that surrounds the whole thing. That is a part of the whole thing, in that even the concepts here are defined by subgraphs. But in this case, rather than looking at a customer and seeing everything we could ever possibly know, we use a concept that says customer in a particular context and has only a few important surface features. There's a common formulation that goes from data to information to knowledge and then perhaps to wisdom. This is the tooling version of that, where knowledge, structures of semantic defined knowledge, translate data into information, into objects in that world of graph objects. I've used the word a couple of times. The thing that makes all of these things harmonious, that makes it a holograph, is that all the moving parts are made of the same thing. This is like the DNA in the proteins. They're semantic structures that you could print out and read, and with a little help, understand what's going on, or give to someone else who can then understand all the fundamental parts and principles you're talking about. We've made a lot of progress over the years in describing complex systems as knowledge graphs, but the question always seems to arise of what it looks like when there's actual data in the system. When you build something with it, have you seen it in the wild? Does it really work? The purpose of this holograph is to answer that question and make something that works at the level of individual bits of data. So I've put together 3 quick case studies um, to cover ways that a data system has to work. In the first case, information comes in from the outside world. It might be from a website or from a piece of connected equipment, and it enters via a point that, again, is defined by a semantic subgraph. The entry point that says, when data comes in here, register where it came from and when we got it, and then write that data into the core with a timestamp. From there, it bounces against data contract, again, a semantic subgraph that contains the rules to evaluate whether the data is acceptable, and also manipulations required to get it into the semantic language of the whole system. So it's saved both in its native version and then saved again as semantic data, which passes through, again, another subgraph, in this case, one that describes an object like customer, from where it will create a new object or modify properties of an existing object. In the case of a user operating in an interface at the level of the halo, someone who opens a form to change the name on a record, that information will again be bumped against the same data contract subgraph to make sure it's valid even before it's submitted and saved. If it passes that, again, it's written into the core as data, the raw version. It's pushed through the definition of the object that it affects, where it's interpreted as semantic data and saved, and then also rendered out in the world as a change or a new object. The third case study is the one that really unlocks the flexibility and potential that we connect with concept formation and developing expertise. And that is a situation where someone at the level of a builder makes a change to the underlying knowledge graph, to the structures that make the graph objects exist in the world. Fortunately, when you make a change like that, it can have vast ramifications, but this process allows you to test those locally, to take this data core that you know is reliable, you're not going to break, to plug it into your new version of the knowledge graph layer and run a simulation that renders all the data and see what breaks, what doesn't fit, what dependencies you might be breaking or violating, and lets you resolve all those things, as well as giving you a platform for review and approval. Assuming that you've found some problems and fixed them and revised it and gotten a friend to sign off, the changes are then written into the knowledge graph, again, into the subgraphs, which are made of words that you can understand and structures that you can read and that machines can read. The knowledge graph itself, that subgraph, is saved in the data core as a version. So if you had to go back to yesterday's, yesterday's is still there. In addition, as part of this process of pushing it back out to the world, the semantic data that might be affected is updated in the core as well. It's not replaced. So again, you could go back to yesterday's data and see what changed when. When that happens, though, there's a chance that object out in the world will have to be recreated. So at whatever scope the change requires, the system will re-render objects in the world with their new properties, and presumably will notify other users or other connected systems that there's been a change at the level of architecture, and they should keep an eye out for any possible consequences. The inspiration for this model came from the way we form concepts and build expertise. Graph objects in this world have surfaces, visible attributes that we can see, and the process of understanding and using these objects requires us to decide which of those innumerable surface level features to rely on as clues. Experts are defined by their ability to know which of these features matter and to associate some of those surface features with hidden traits, perhaps, while novices can't easily differentiate and may not even be aware that there are hidden traits. If you've ever looked at a foreign data scheme or object and seen a whole big list of things that relate to it without a sense of what most of them mean and when they're important, that's the novice experience of looking at an object. But what expertise does, what the development of concepts and knowledge does for us, is that by seeing things that are hidden to novices and perceiving clues that might otherwise go unseen, and then giving those concepts names, bringing them up to the surface, coding them into the knowledge graph layer, they become visible to people who may not have that level of expertise and usable for problem solving scenarios. Um, a quick sort of real world scenario from my own experience in the realm of marketing data. Um, we have the object of the customer with a whole bunch of associated attributes, but that's just too much to look at. So we have the concept or a view equivalent of the purchase history that shows just the customer and what they bought. And we have a search pattern, a query that finds people who've made a purchase less than 2 weeks and hadn't bought anything in the 10 months previous. Putting those together returns a swarm of objects that fit that pattern. And there are a whole bunch of different interface conventions that I'll be describing in the near future to help us make sense of those. But you can sort of see how a bunch of different objects, a bunch of different customers and their own histories show up as a result of the search and give us ways to relate them and arrange them. And in this case, to look even more deeply with expertise and realize that these people are making purchases in the 2 weeks before their child's birthday. So perhaps the idea of a parent whose kid is about to have a birthday becomes a concept that can be registered in the enterprise and can be used by people, used by marketing teams, used anywhere it could be helpful. That's the power of concepts and developing expertise. Part of the promise of semantics and knowledge graphs in this realm is that they allow integration and interoperability. The objects in these holographs, because they're made from the same underlying language and the same conventions and the same human and machine understandable logic and language, they can interact with each other. And even across domains and different kinds of objects, patterns and relationships can be determined that might otherwise have gone unseen. As well, they allow integration with outside structures of information. The promise of the semantic web assumes a sort of fixed language that all websites share. Research communities share different sets of terminology and data standards around biology, around proteins and genes. And with a holograph, all it takes is the right subgraph to translate incoming and outgoing to make it possible to publish your information in a way that you know the world can understand, or to take in information that someone out in the world or hundreds of people out in the world have published using the same standard. Facing a data transformation project, especially if you've seen a large and convoluted and complicated looking structural knowledge graph, can be a prohibitively daunting process. It's important to remember that the hollow in this name, the entirety of it, does not mean that it contains everything in your organization, everything your organization knows and cares about. That is possible. The technology and the model support that, but it's just as suited to starting small, building a logical twin of a particular project or process or domain. And the conventions and the approaches that you establish building even a simple logical twin of a process in one of your domains will expand and extend throughout future projects and throughout the rest of the organization, which results in perhaps a set of holographs or holographs within a set of domains that operate as separate things, separate data products, but are also interoperable, can be connected to each other, can be moved from one domain to another even. There may be insights that we find in one realm that are useful someplace entirely different. So starting with clear questions and conversations that establish what we know about what we care about and what we know about how it behaves will do most of the startup work that can lead into a radical and widespread data transformation. But it can start small. It's something that you can build quickly, that you can build in an emergent situation in the case of dealing with a new outbreak of wildfires or disease or some new technology. The fact that everything in it is related and harmonious and contained doesn't mean that it's large and complicated. It means that it can handle things that are large and complicated. The power of concepts and abstraction lets us deal with things as analogies. So I'll give you one last analogy, in this case that describes the system, but the same thing can apply to things in the system. The core of data is solid ground under your feet. The knowledge graph layer describes everything you know about, let's say, fish and lures and equipment and bodies of water, weather formations. It's the rules of the game of the world around you. That world is the world of the graph objects, all the fish, all the lures in your tackle box, all the temperature gradients, and the currents and the weather fronts. And what all these things allow is for you looking through the lens of the halo to see through the water, to see every level of the water table, to see the fish, to know what kinds of fish they are, to see where there are eddies in the current where they might hang out and feed. That sensation, being able to see everything you care about, that's what your data should feel like. That's what it should feel like to use your information and the systems that help you investigate it and learn from it and explore it. I invite you to ask any questions or to contact me at any time about um, semantic engineering, which I'll be happy to talk about. I'll be writing more in the near days about user interfaces that are enabled by this approach. Um, and yeah, thank you for your time. And Joaquin, thank you for putting all this together. This has been great.
Thank you, Daniel, for this wonderful presentation. I'm a fan of Prezi now. You brought it back to the
Isn't that great?
mainstream. Yeah, it's so awesome. I like the roller coaster feeling. I don't know.
I hope I didn't make anybody car sick. But
Yeah. I just want to say that yes, if you have any questions, comments, concerns, feel free to add it below. We'll get to respond to them. If not today, then throughout the week. I know some people are going to be watching this live today, or if not during the weekend. Um, but I want to say I really enjoy the perspective that you bring and the visual elements that you brought as part of your presentation. Um, I really you have a lot of quotable things that you said. Data is ground under your feet. All the moving parts are made of the same materials. There's an infinite number of details to look at, but really we have to scope it down and look at it in manageable chunks. Again, I want to say that your background in marketing is an incredible perspective to bring forth. I know there's a lot of use cases around customer 360, and I know one of the easiest ways to add value is to find a way to reconcile all the different fragmented perspectives of what it means to look at a customer from the perspective of marketing and advertisement, particularly in that domain when there's so many freaking tools. There's so many tools, and they all give you hints and angles, but they don't paint the full picture. Um, is there anything that you can tell me around that? How you would approach that holograph engagement?
I mean, the biggest thing, the two sort of quotable words that I would suggest people look up are the term data centric um, and the term semantic engineering, which I'm trying to establish to cover the use of language and semantics actually to build operational systems and to interact with them. Everything from semantic ontologies to prompt engineering. But the most important part really is that data-centric paradigm, that the ways we've done things in the past have put us in silos and boxes, and we've always known we could stitch everything together at the end if we need to. The problem is we need to at every point along the way, right? If we knew what we were going to need to ask at the very beginning, that might work. But the nature of intelligence and learning is that we figure out what we should have asked at the beginning. And by keeping that permanent time-stamped data core and being able to change how we understand it and what we do with it, we're able to learn. We're able to improve the way we think of things, not just fix where we're wrong, but maybe we come up with an entirely new name for something. Things that we like the idea of somebody who's getting ready to buy presents for their kid, right? It's what we call a non-lexical category. It's something that we know exists, but we don't really have a name for it. Finding those things in traditional data systems is beyond difficult. So, we need systems like this where we have access to all the information without being blinded by all the information. You know,
I
the
like Yeah, I really enjoy that you're putting that perspective because that reflects the real world. Why do we have to do workarounds with experienced designers to create customer journey maps and manually reconcile the customer journey? Why are we not able to get a full perspective from our data infrastructure, which is the whole point of it? It's supposed to track the movement of our customers so we can provide more value faster in more convenient ways.
right.
And
Because
I just,
most often we're doing it in a platform that does a pretty good job of most of what we need to do,
mm,
but it's not us, it's not ours. You know, we don't have a data construct that is the customer journey. You know, we can look at it and say, this is what we think, this is what we care about, this is what information we can take from it, this is how it's going to change next week, and revise everything. So we need architecture that makes it possible to do that. And all that really means having our data and knowing it and having it represent us and what we can do and what we can see. So if the platform I build for somebody goes out of business, is hit by a meteor, they've got their data, they've got their semantics, they can plug it into anybody else. And in a frighteningly fast turnaround time, especially in the case of an emergency, you can build an entirely new system that has all the objects, that has all the rules, that has all the principles behind it, because you have the data, not because you're beholden to an application. You're locked into a single platform. It won't cost you millions of dollars to move from, Salesforce to NetSuite,
it's even cheaper.
because you've built the thing already. You know, you've done most of the hard work. So now we have, especially now that we have LLMs that can translate from one language to another, we don't even have to be religious about what language we embrace. You know, we can change once we have the semantics and the logic, we can move that even from one language system to another. Because what matters is, yeah, the language and the information and the knowledge that it captures.
I just want to end with a positive note from John O. Gorman, the disambiguation expert himself. He's paying you a compliment. Great presentation, Daniel.
He's been
And
responsible for one or two of my brightest light bulb moments. So I appreciate that. That's good to see. Thank you, John.
all right, well, get in touch with Daniel directly, and be sure to rewatch and reshare this stream.
Thanks a lot. Take care.